I'm John. I'm a ship modeler.
Hi, John.
Hi, John.
This is not an AI generated briefing. I wrote it a few years ago. I'm going to try and zip through it as quickly as I can. There's a lot of words at the beginning, and I'm going to use my Cold War era many flag briefing laser pointer to hit the high points of each slide to kind of keep things moving along. I'll take any questions, but sometimes the answer is on the next view graph. So if you don't get an answer after a couple of view graphs, then please raise your hand if I'm not being clear about something. I like to explain my process very quickly. I'm a very inquisitive guy, and I was a tour guide on the Wisconsin for about a year. And I had a lot of people stream by me that didn't even know what questions to ask. You can believe that. I know we're a different kind of audience here, but it was surprising how little knowledge the general public has about the kinds of things I'm going to talk about here. So I'll try and get through them as quickly as I can, but hit the salient points, I hope, within maybe a half an hour to 40 minutes. Working with my assistant here.
You more loaded there?
Sure. The topic is naval gunnery. And it first started from my tour on the Wisconsin. I was wondering, how does a rolling and pitching ship hit another rolling and pitching ship, both of whom are doing 20 odd knots in heavy seas, and expect to actually hit something? And it took a long time to get to the point where that actually was happening. I'm going to step through the beginning to the end. And I call this, oh, that's my mirror image.
Yeah.
Okay, so everything's going to be backwards.
I don't know why.
Trust me, we really do have the briefing here. If you don't, you're getting
Why? What the heck did you share?
Should be
Place your deflected video on.
should be able to do an entire screen. I don't.
So, any questions about my laser pointer?
What color is it?
Want to see?
Yeah.
Okay.
Cat scratch.
Rylan, when you share the entire screen, once you open up the
I am next.
slideshow, it should
Sure.
appear.
All right.
There we go.
I think you can see it on
No.
Okay.
If you share the
Thank
entire
you.
screen now that you kind of maximize
Whole bunch, all right. I'm clicking on it and nothing's happening.
Okay, any questions?
that. Thank you. Thank you, Shelby.
There we go. Okay. Now we just go to the,
It's
from the
up
beginning.
there.
There we go. Left.
What are the online people?
Left.
All the way
From the beginning. There we go. Okay. Sharing the screen. Do you want to keep sharing it? Okay. This is a picture of Missouri on the range down in Trinidad. And what's interesting about this picture and another one you'll see later is you can actually see the shells right there from the number 3 turret. So what led to all of this? And my presentation kind of stops around World War II because that's when the big gun goes out. There we go. So I've broken it down into categories here, eras, I guess. This is the people involved. It's a very complex story. As I dug into it more, I found there was an awful lot more stuff going on than just putting a shell in the barrel and shooting it. And it's a cast of characters, click. Cast of characters, click. And you can see it covers a lot of ground. Next. Guess that's me. Next. It's always a moving target, literally and figuratively. And so I'm going to trace it. I thought to myself, where did it start? What did it look like when it began? Because it sure as hell wasn't cannons. So I break it down into eras. Now, the Stone Age, next. The Russell Crowe Age, the Iron Age, Industrial Age, feedback and control, and finally the end of the big gun. Next, please. And where we are now is their relics. Next. The rocky start was ships had people on them with rocks that threw the rocks at other ships. And that's how it really began. It was a very close range thing. It was probably 10 yards, and the rocks weren't all that big. And there was a real issue of shore bombardment. They had catapults, but probably one of the problems was that triremes and biremes had plenty of rooms for oarsmen, but no place to put the weapons. So they were very limited in the amount of ordnance they could carry and very limited in the amount of throwing of ordnance devices that were on the ship. It began about the time of Julius Caesar, probably started in China before that. There's many things did. And it's becoming more common in the Middle Ages. Next. This is the first recorded ship versus ship battle, gunnery battle. And again, it's probably catapults, not cannons. Next. This didn't happen until 1501, as you see, when they actually started cutting the gun ports. See, all that are making wooden ships are having trouble fitting. That's about when your troubles began. And all throughout this whole presentation, you'll see the same thing over and over. We need bigger guns. We need bigger guns. And I'm going to try and go through the cost of bigger guns as you build and develop ships to carry them. Okay. And here's some of the bigger guns make bigger holes, but various other things are affected, like bigger projectiles produce more recoil. You need to control the recoil. Bigger guns require more powder, more shock weight, and the gun barrel grows in greater proportion to the size of growth of the object you're trying to shoot, like a cannonball or a rock in the early days. And this is what I referred to earlier. The triremes had plenty of room for oarsmen, but not so much room for the projectile shooters. Next, please. Tactical ranges in the Stone Age, probably not even that far. More powerful gunpowder and iron balls made a difference because you had less windage, that is the wind that goes around the ball and out the barrel without doing any effort to move the projectile out of the barrel. And think of it in terms of Ben-Hur, the biggest ship killer was the bow ram, not the weapon on board the ship. More speed, if you remember the movie. Okay.
Yeah.
The Master and Commander age, I got a chuckle out of that. Next, please. This is the classic duel at sea that you think of in the Master, what I call the Master and Commander age. And you remember Russell Crowe. Scene from Russell with Love. After 3 glasses of wine with a doctor, Aubrey forgets the gun is loaded. No wonder the ship is named Surprise. And here's what a typical gun deck, I believe this is Constitution, the main gun deck. And you can see
Victory.
the Victory, okay, cool. And what a cannon looked like in those days, kind of a wooden carriage, wooden wheels, and then it has to be lashed in to check the recoil, and so you didn't end up with the gun going across the deck. And here's a progression of the gun barrel sizes, and you notice the size of the ball doesn't really change that much, but the size of the cannon changes a lot. And here's a cross-section brief of what it looks like.
Is the intent for that longer range?
Well, the intent was to put bigger holes in other ships. Longer range was a byproduct of that because a bigger gun shoots longer. So, and there are problems with that. Next, please. Well, here's what you're looking at here. And when you start getting a lot of this iron this high up in the ship, you start to run into stability problems. And also, you got to get the gun projectiles from down here and the powder from down here up to there. So the reload times was on the order of a couple of minutes per gun. And you had to aim, this is kind of an extreme example, but you can see that the guns, next click please. The guns may not aim where you want to aim them. They'll end up here if you're rolling in that direction and he's rolling in that direction. You may get some shots on the main deck, but the reverse is true. The gun port limits the elevation, the range of elevation. So So therefore, it limits how far away you can shoot and hit what you're aiming at while the ship is rolling in pitch. They hadn't solved that problem then. Next. There's also different kinds of ammo intended to do various things. This is the knock holes in the sides of the ship. These are more toward dismasting or tearing the rigging. And that was the way most battles were decided, was not in sinking the other ship. That was actually fairly rare. Usually it was dismasting them and making them unmaneuverable so that you could offer to come around and use raking fire across the stern, kill all the people behind the guns. That was the objective. Next. This evolved into a line of battle, and what was kind of gentlemanly about it is they usually paired same size ships against each other and the smaller ships in the back of the line against each other. Very gentlemanly. So it was a fair, quote unquote, fair fight. And that's what it looked like. And as I'll make the comment again a little later, the problem with this arrangement is that you have to aim the ship to aim the guns. So if the ship that you're shooting at maneuvers, you have to maneuver to make up for that in order to get them back within range of your guns. You get bonus points if you can do something called, next click please, crossing the T, which allows the adversary to bring more guns to bear in raking fire the closer you get, which does more damage to the gun crews than you would if you're just trying to punch holes into very thick wooden sides. And as I say here, there's always some asshole that wants to do something different. That was Nelson at Trafalgar. He basically bisected the French line, which hadn't been done up to that point. And he ended up getting into a position where he was, in fact, crossing the T of his own choice and shooting along the lines of ships rather than into the heavily protected sides of the ship. Okay. Ships of wood or men of iron. Next. Half a pistol shot. So that's less than 100 yards was the engagement range. And these cannons had to be withdrawn, loaded from the muzzle, and rolled back out. It was about 2 minutes to 3 minutes for a reload cycle per gun. And then you got all these folks scrambling up from below decks with the shot that wasn't in the ready service ammo locker next to the gun. And then swabbing out, making sure you got all the powder out of the barrel so it didn't prematurely set off the powder when you put it in before you rammed the cannonball down. Next. And bigger guns, limited elevation and deflection because the gun port's only just so big, so you have a narrower range of degrees in both directions. And usually, next slide, please. This is more likely to disable the enemy ship is if you take down the rigging and the sails than if you hope you'll punch a hole in the side of this very thick. Oh, yes.
This third thing says the muzzle loaded cannon with some exceptions. Were there such thing as breech loaders?
Later on, yes.
Later on.
That was the ultimate evolution of this particular arrangement was breech load. And then later on rifling too, but that's a ways down the hill. Okay, next. Gunnery is an art, and you had good gunners and not so good gunners. And then began the decline because the Brits ran out of people to beat. And there was a period of time up to and almost including the American Civil War when the captains of the ships got more bonus points for having a bright work ship than one with powder burns all over it that hadn't been cleaned up. So they got more bonus points for not shooting and not being good at gunnery than they did at being at gunnery. And literally, there's a good book out on that. It's called Dreadnought. And a follow-up is Castles of Steel. They're both work together. It discusses this in great detail, including the time between Trafalgar and after the American Civil War, when the Brits started to get more concerned about accuracy in gunnery than actually in polishing the brass work. Okay. Where do we go from here? Next. The Iron Age. Somebody got the bright idea of sheathing that wood on the sides of the ship with steel. Well, iron at first, of course. Next. And an engineer, of course, got the bright idea, throw Newtonian mechanics at this. The whole idea here was to reduce blow-by, and you had to have more control over how the gun barrel was bored, and also how closely matching you could make the iron ball that was going out the gun port in order to capture more of the explosive force of the black powder that expelled the shell, expelled the warhead. And you can see there's an upward turn here around 1830, when suddenly you start to get bigger guns, ironclad frigates, and you start to get longer engage. Year is here, longer tonnage, but this also translates into bigger guns. And of course, right around 1850, 1860 is when turrets start to make their show. And there were actually two designs. Next, and I'll show you in a moment. But it was a simultaneous development without any interaction between Ericsson and a British counterpart. Right around the same time, they came up with generally the same idea. I have two pictures of what the two versions look like, and they're kind of a wash. But we start to see the ram bow again as a ship killer. You're still at a really short range. If you're only engaging at 100 to 200 yards, you're pretty close anyway, and ramming was more common then than it is now. Armor-piercing projectiles were 1870-ish is the records I saw. And sales augmented, then replaced self-generated. This is where we get into the acrimonious debate between the sticks and strings model builders and the steel Navy types like myself. Back one, please. Forward one. There we go. That's what the two turrets look like. This is the Ericsson turret. And this is the Ericsson turret with the Dahlgren gun. And then this is the British version. And they kind of look the same. This spotting tower here was not on the original monitor. But that was the only picture I could find. And here's the Coke bottle shape of the Dahlgren gun. See it here. And ignore the mystery ship thing. That was years ago. Next, please. And when you talk about ugly ships, I mean, this is a plug ugly ship. But notice that it's a combination of side ports and a ram bow of distinction. And a couple of eyes here, I guess, so you can see your target when you ran into them. Okay. So, of course, the real crossroads is the Battle of Hampton Roads, where you've got a ship that has to be turned to aim the guns and a ship that can just go the best way for the hull and turn the turret to engage. And it was fought to a draw, but this is the first time anybody had done any of these things, so tactics kind of developed on the fly. We know after the fact that there were a couple of places they could have hit Virginia that would have sunk it if they hit it in the unreinforced section of the bow, because she had already broken the bow probe off in another ship that she had rammed earlier, I think the Cumberland. Yeah. Okay. So steam power increased the area for maneuver, and also the nearest ship was now not necessarily the best target. If you had a small ship in the way, pounding the crap out of it didn't make as much sense as going for one of the bigger ships. And there was a transition period when these ships were half steam and half sail, and it was, again, trying to figure out how all this works. And it also led to a development where there was an offshoot, there was a branch of the Navy that had engineers in it, meaning power engineers for the steam turbines and stuff in the ship, or what steam engines, not turbines yet. Battle ranges increased out to to 3 miles by the 1890s, and they now had to increase the aperture for the barrel to raise so you could shoot further. Heard it. This is easy enough to read. I'll let you read it. But now you start to run into this longer time frame, which means you got to lead the rabbit. When he's only 100 yards away, you don't have to do much leading. But when he's 3 miles away, or even further than that, you got to figure out where he's going to be by the time you reload and account for his speed. If you can accurately estimate his speed, where that shot has to be, rather than where ship is now. That leads you into a problem that has a lot of complexities. What was not understood at first is that this was not a hemispherical shape to it, but actually as the shell slows down, it drops at a greater angle of fall. There's also a built-in angular drift, which I'll get to in a minute, but they began to notice that at further ranges, the shells kept bearing to the right. And they couldn't figure out at first what the cause of that was. Some of it had to do with the rifling, but the other part of it was the Coriolis effect. And they didn't realize that right away. The longer the range, the more offset you're going to have when the shell finally hits the other shell.
Can you explain the Coriolis?
If you notice, the wind currents and the sea currents turn clockwise in the Atlantic Ocean. They turn counterclockwise south of the equator, but most of the stuff is going on north of the equator. So anyway, you get into this. If you've seen some of these movies like The Enemy Below and other World War II movies, or Run Silent, Run Deep, you see the is-was computer. And that's kind of what this is. Here's me, here's the bad guy. What angle do I have to shoot? And then I have to allow for him to travel a certain distance before I get my shot off. How do you figure out where that's going to be? And next. And the one kind of surprising thing is in the Spanish-American War, the US Navy won by having a less bad hit percentage. And it was under 2%. Under 2%. And they counted the number of holes in the Spanish ships and they counted the number of holes in the American ships. They were just a little bit better, and that was enough to carry the day. And I don't think the Spanish were quite ready, so they weren't as prepared. But one solution, of course, is to shoot more quickly. So this led to the development of rapid fire guns, quick fire they call them. That's what I'm saying. Quick fire guns. And anything that would speed up a 2 to 3 minute reload, like breech load. Sorry, thank you. Breech loading could allow you to shoot more quickly, having something other than just putting powder in and tamping it down and then putting in the shell and then shooting. Anything that speeds up that whole process. This led to elementary fire control computers, which were in later days made of servos and hydraulics. And I have an example that you'll see on the Iowa class in a moment. But that was one way. Adopting continuous aim, you can see, if you've ever seen some movies, World War I or World War II, you see the guns tracking back and forth like this as the ship rolls and pitches. So when they're ready to shoot, it's already aimed and ready to go. Boom, off it goes. That's continuous aim. Okay, next. Built-up gun, that means it's made up of several cylinders rather than cast as one big chunk of iron. And it's a move toward automation. There's some material science improvements, meaning better steel and better powder. Next. They were still limited by materials, but you can see they're gaining on it. The development of the guns spurs further development of the mechanism to produce better guns. And everybody wants bigger guns, so they're finding ways of making bigger guns that shoot more quickly. Next. So the Brits came up with this idea. If you look at some of the older designs prior to Dreadnought, you see a lot of different caliber guns. The Brits said, screw that. let's just focus on big caliber guns. And they had some smaller caliber guns to deflect torpedo boats. So you might have a 1 or 2 inch or 3 inch gun to complement the 12-inch main guns of the 5 turrets in a yep, there we go, of a dreadnought. Anyway, the design goals: largest possible main battery, fastest speed, and the assumption in those days was you had to have armor to deflect the same size caliber gun being shot at you that you carry. You can see some flaws in that, but anyway. So next click. The problem was, if you look at design studies, you got to pick 2. You can't pick all 3. The ship would sink. You just can't put enough armor on a big gun ship and have it go fast enough and have it float. Yeah. I highly recommend the Friedman series on U.S. Navy ship design, carriers, cruisers, battleships. They go through the step-by-step process of how they made trade-offs, how many turrets, what size guns, and all of that. And it's all part of the reaction that follows Dreadnought and World War I. Next slide. World War I was seen as being triggered by the race to build bigger and more battleships by the Brits and the Germans. We were way behind in that, but the primary drivers of this, bigger and more ships at any price, which almost bankrupted the Brits, was what triggered the I've got to beat the other guy, and it started World War I as one of the prime drivers of World War I. So after that, the London and Washington treaties set about design limits on the size, tonnage, the number of hulls, and restricted the gun barrel size on various classes of ships. Battleships were, if I remember right, 14-inch guns were the biggest you could put. They also had a holiday on new battleship construction, and you were stuck with what you had up to a certain point, and you had to scrap the rest. That's where some of our aircraft carriers actually came from. The Lexington and the Saratoga were both battle cruisers, originally laid down as battle cruisers. They were converted to aircraft carriers because we could do that under the treaties. And the interesting thing that came out of this, since I did this briefing, I found some interesting things here. This trade-off, what a cruiser had to be 10,000 tons to meet the restrictions. You could go under that, but you couldn't go over. And it was your choice whether you had 6-inch guns and 8-inch guns. Well, everybody wants bigger guns, 8-inch guns. So they were limited to 9 barrels. You pick the number of turrets. Usually it was 3. But the alternate was 6-inch guns. You pick the barrels, and you could get 15 barrels of 6-inch guns in a turret of 3. So you'd have 5 turrets. And they went back and forth. Should we? And what were the trade-offs? And it turned out about this time they developed a 6-inch 47 that was a rapid fire 6-inch gun. And when you did the math, from 15 barrels, you could put more lead on the target in the same amount of time as you could with 8-inch 9 barrels. And when the Japanese saw these things in action, they thought they were like 6-inch machine guns because they were able to fire up to 10 rounds a minute per barrel, as opposed to more like 5 or 4 rounds per minute for the 8-inch guns. And these were specially designed shells. In fact, Helena smothered a number of Japanese ships with fire until she ran out of flashless powder and started to shoot non-flash powder, flash powder, and the Japanese hit her with torpedoes and sank her. That was kind of a mixed blessing. But it was an amazing thing to see this thing in trials for the first time. It was just like a 6-inch machine gun, bah, 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 from 15 barrels at once. Anyway, that's a lot of lead, and it more than made up for the lack of bore size. So with the battle cruiser, the British invented the battle cruiser in the 1910-ish time frame, just in time for the Battle of Jutland in 1916, I think it was. And what they did was they had the same but smaller number of big bore guns that the battleships had, 14 inches. They had the speed of a cruiser, 30 odd knots, but they had the protection against 8-inch shells. And it works great. You know, number one, big guns kill cruisers, which they expected to be up against cruisers, and sufficient speed to avoid battleships. But there was a third possibility they had never considered, and that was an aggressive application of battle cruisers against retreating cruisers led them into a nest of battleships, which cleaned their clock. They did a lot of damage. They sank several battle cruisers that just blew up because they were not properly protected. So now we're into the feedback and control age. We're in between the wars. There's a lot of development work going on to try and speed up the fire of guns, make them more accurate, because it was clear that the first telling shot is going to be the winning shot. There was a lot of effort put into focusing on how to get as many shells out of the barrels as quickly as possible to make the first couple of hits on the enemy to disable it. And so they looked at a lot of things. I'll show you examples of all of these in a picture just in a moment. But there were actually gun sights that were developed for anti-aircraft guns that automatically calculated the lead angle for a fast-moving aircraft. Ford did that in the 30s. And if you look at some of the 20 millimeter cannons on some of the cruisers and aircraft carriers, and also some of the battleships, you see a pod on some of them, and that's the actual range determining it. If you go back to the math of it, if you can click, 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 and follow an aircraft, you can develop its track. If you can develop its track, you take the first derivative of that, and that's the speed. You take the first derivative of that first derivative, and you get the maneuverability of the target. You come up with a calculation that tells you where he's going to be if everything stays the same in about 5 to 10 seconds. So even boys off the step could, if they used it properly, could figure out where they had to shoot to lead the rabbit and get a substantial number of hits that they probably wouldn't have if they were just trying to gauge it by eye. And the automated loading process, bringing the shells up, ramming the shell in, ramming the powder bags in, closing the barrel, shooting. On the Iowa class, you could do that in 30 seconds for each barrel. But that's still a little ways down the road. This is in the age before iPods and before electronic computers. It's all done mechanically with gears, switches, and also hydraulics. I'll show you what one of those computers looks like. Okay, next please. So, yeah, this is what one of these optical rangefinders. This is in the day before the era before radar, but it's a set of binoculars with a really wide baseline so that you can triangulate the range by the difference in the angle between this rangefinder and this rangefinder. And then it changes as the target gets closer. Next, please. And here's what the combination of things looks like. Searchlights in those days, no radar. This is one of those big rangefinders we just looked at. A range clock which tells other ships what angle this ship relative to its the relative bearing. And then these are the deflection markings that kind of reinforce what the clock says. Because each gun barrel, each turret could be firing in a different direction. And the first use of aircraft is spotters. Yep, there you go. And the thing was, when the first aircraft carriers start rolling off the blocks, the first real ones like the Yorktown class, most of the naval aviators by far in the US Navy were flying seaplanes that are used as spotters off of cruisers or battleships. That's where the bulk of naval aviation is before the war starts. Okay, so you can see it's a complex task, including other visual means at the top of Gene Berger's lattice work pages, page mask. Next. And here's a mixed bag. You got 8-inch guns here on either the Sarah or the Lex and biplanes. What a combination. Next, please. Then comes radar. This is a more advanced than the original radar, but you've got, this is the range and this is the height finder. So it moves back and forth independent of this cluster. And then this is where the men are that kind of sort all the information and send it to the combat information center. Now, this is what one of those computers looks like. And the question I always had in my mind is, how in the world does a ship that's rolling and pitching, doing 20 knots or 20 plus knots in a heavy sea, shoot at something else that's moving at 20 or more knots in a heavy sea in a different direction? And the answer is this computer relies on what's called a stable vertical, which is a pendulum, nothing more than a pendulum. And in spite of all the rolling and pitching, there is one point, not for very long, but there's one point where the ship is perfectly horizontal and vertical. And you use that to engage the gun firing circuits. The gunners can push in the firing circuits, but nothing's going to happen until the stable vertical says everything's flat. Off they go. Even at that, as you'll see in another photograph, there are some interrupters in the circuit so that all 9 guns on an Iowa class do not fire at the same time. They're milliseconds apart, and you could see that in the first picture for the opening title. You could see the individual 3 shells. They weren't in a group of 3, they were staggered. That's the result of that interrupter in the firing circuit to lower the stress on the hull so you don't have 9 booms all at once. So that's what it looks like. The other thing that the US came up with in the middle of this period of no building of ships was a thing, they developed a thing called, you know what, we can develop an immune zone. And the immune zone, to put it in simple words, is the closest the good guy can get to the bad guy without a flat trajectory penetrating the side armor. And the farthest out is where a plunging fire just doesn't penetrate the deck armor. Usually it's not quite that vertical. It bounces off the deck armor. And if you're in between those 2 limits, you're in the quote unquote immune zone. You're less subject to disabling fire. Now you look at, this is Wisconsin, and you look at that and you say, how is a battleship that T-bones a destroyer going to end up with this kind of damage? Because it's not protected. The armor is way back. The armor belt is way back over here. This is all just hydrodynamic fairing to make it go fast, but it's not protected. But hitting it there won't cause disabling damage to the ship that may lead to its sinking. The same thing is true out toward the stern. You protect out about as far as the rudder post, and then beyond that, it's pretty much unprotected. So that's the other part of this. You have an immune zone, and you also have a protected citadel in between about the number 3 turret and the number 1 turret, plus a little bit to cover other things like aviation gas and a few other things that could be very dangerous. So the combination of all these things is what led to a redesign in the ships. It's very well covered in those Friedman books, but I've seen it elsewhere too. It's a fascinating subject. To me, it is anyway. Next. So we're back. No. You can read this as well. I hate to read to people. The one thing, we did a lot of practice between the wars, and we got really good at hitting target sleds. but there were constraints on how the target sleds were towed, because if you had a target being towed directly at a battleship, the tug that was towing it was in the line of fire. So most of these exercises were perpendicular to the line of fire, which is cool up to a point. But the hardest thing to solve is range rate changes, not bearing rate changes. And it was found out at next you go ahead. When you look at some of these target laydowns for the exercises, you can see that with everything they had going for them, there was no radar in these days. But you can see how much of the scatter is nowhere near the ship. It's long or short. It's not. The bearing is right on in many cases. They're really close. But the range, it's very hard to estimate range rate without something like radar. Visual doesn't keep up with the movement of the ship. Next. So anyway, here's the tonnage limit thing. This is when we started building ships again, we stuck to the exact limits of the first Washington, then London treaty limits. There was an escalator clause in the London treaty limits that allowed, if you had a 14-inch main battery, you could upgun it to 16 inches, but the ships were already partly built or designed anyway. And they found out that they could upgun to 16 inches, but they couldn't add extra armor without screwing up the stability of the ship. Japan, we know, went way beyond. They had screens around the Yamato class as they built them, so you couldn't see how much bigger they were than the treaty limits. Made it clear. But on the other hand, the US and the UK developed radar, gunnery control radar, larger projectiles, both armor piercing and what are called high capacity rounds, which clears the deck of more extraneous stuff like anti-aircraft guns and crews. And now we get into the use of servos. There's an excellent book on the development of servos for gunfire control. And I got it here at the bookstore. It's called Between Human and Machine, and it's an MIT Press book. It goes through all of the development of servos, then how you made them responsive to moving the turret quickly without overshooting and all that kind of electronic stuff. This says it all as far as where the war went. This is Oklahoma, which was built in the teens. And this is Wisconsin. And you can see it's not just the sharp bow, it's even the turrets. That's a box over what used to be a turret, but you can see the size of the guns. It's just a huge step forward. I've heard it said that at the Battle of Midway and then at the Battle of Santa Cruz, we fought the original Japanese Navy to a standstill with our original Navy. Then we brought in our second newly constructed Navy and cleaned their clock after that, after 1942. And this kind of is a good example of it. This is what the barbette and the turret look like, and the auto load bringing the right shell, either high capacity or armor piercing, bringing it up, ramming it home, putting the powder bags that come from down here up a different hoist into the back of the gun, ramming it home in 30 seconds. So I've talked to some gunner's mates. I said, can you hear me talk to you? Oh yeah, I can hear you. I thought your hearing would be gone by now. He said, what are you talking about? It's quiet in there. If you stop and think of it, you want all the energy to go out the barrel. So the sealing is so good that they just had to be careful. They were alert for when the recoil occurred and they weren't crushed by the recoil, not the noise deafening. Next. Now back to this. This is that angular drift that was caused by the spinning of the rifled shell and the Coriolis effect that causes it to drift off to the right. So you now have to compensate for that. When you've got everything else figured, where the guy's going to be at a certain time, you also got to calculate for where the shell is actually going to be and dial in some more deflection to get it to the right place. And when they when they improved their understanding of all these different physical forces, it became more important at longer ranges, obviously, because the deflection is more at the longer range. Next. Now you start to see we're pushing out. That's about 17 and a half miles. Pushing out the bigger guns, because they're bigger guns, carry further, and you now have to figure out how you're going to engage at 20 miles or less, sometimes at 10 miles for cruisers. And this is just a spaghetti chart, so all this stuff is all hooked up. But it's, as I said at the very beginning, it's a very complex combination of things in order to do a very simple task. Next click. Now here's the two turrets of Missouri, and you can see the stagger of the shots because of the interrupter circuits.
John,
Yes.
how long did it take for a projectile to go from
30 seconds.
30 seconds?
About 30 seconds. So about as fast as you can reload, you're ready with the next shot by the time it hits. So that's one example of how big the shell is. Next click. This is one example of how big the barrels are. There's a Volkswagen. And that's about the weight of the shell, the HE shell. And this is, back one please. This is done this is in the British Ordnance Factory, but if you go to the Washington Navy Yard, you go in where some of the models are, you see where they used to be doing the same thing with 16-inch guns. Because what you had to do is they had a time limit or a use limit of 300 rounds per barrel before they had to replace the sleeve with the rifling on it. Because what happens is at the front of the barrel, it starts to extend because of all the wear and the weight of the projectile slowly inches the outer edge forward. So it stretches the liner in the barrel. So 300 rounds, and that's about a ship fill for most of the Iowa class, is 300 rounds per barrel. Some of the other barrels were a little bit more because they have more room in the ship for the forward two turrets. But that's, believe it or not, that's the limited lifespan of these guns. Next click. Missiles are longer, we all know that. So that's why you don't see, and you can't hit very many military targets 20 miles inland, even if you were on the beach with a battleship. You wouldn't be on the beach, of course. So they've kind of fallen out of favor in spite of what some people think. Next, please. I put in a picture of a railgun. I mean, who knows? I don't know where development is on that. It kind of lacks the character of a 16-inch Iowa class gun. Damn it.
Is there a rumor we used it a couple of weeks ago?
I've heard rumors.
Rumors it was an accident.
But consider the source of the rumors.
Was it an accident?
And which way did it go?
Until Iran.
Is that right?
Yeah.
Haven't
That's
heard
the
it.
rumor say.
Haven't
What
heard
is
it.
that? I've not heard of it.
A railgun?
Yeah, railgun.
They mounted it on a non-combatant for test purposes.
And then a Zimwalt like that.
That's right. It's electromagnetic. Electromagnetic.
It has the projectile is just a projectile, so it resides solely on kinetic energy for the destruction that it does. Because it is traveling so fast, so far, that it obliterates what it touches. Crazy.
Yeah, they're beautiful in orbit in an atmosphere.
Successful test fire of a shortened down version of that. Did do a test fire last week.
Well, this picture is probably 6 years old,
Yeah.
if not older.
Right.
Yeah.
It's been into development for a while, but production rate one did last week, and supposedly it did work.
It was supposed to go on the Zimwalt.
The electricity
failed.
that it takes to run that thing.
$10 billion failure.
The limiting factor of
It's not the
total electricity.
Did your study include the battle between Bismarck and the Hood? I understood that a plunging fire
Yep. That's correct.
took out the Hood.
The original Hood design was back in the 1918 timeframe. It was just post World War I. And if you recall, the Battle of Jutland, the the Brits had at least 3 battle cruisers that met the same fate as Hood, just blowing up with very little fire.
Well, the Germans must have really figured out this stuff.
I don't think they did. They
Oh,
didn't.
really?
They didn't
Like
know
the
it was under design. They just shot at longer ranges and got plunging fire. And holy shit!
Yeah, they never upgraded the hood. They never took her offline.
That's right. They were planning to reinforce the deck armor and never got to that point. What I remember.
Budget. Yeah.
Schnapps time,
Yep. What's that?
schnapps time.
Yeah. Well, now here's an example. I like this picture. These were taken at the Washington Navy Yard. And you can see, as I say down here, 16-inch 50, 1, 25 inches of armor, nothing. And for those of you who are not familiar with the term, when you see a gun like this, and you say it's 50 caliber, that's like a machine gun. In this case, the usage of the 50 cal is the barrel length is 50 times the caliber of the gun. So it's like 57 feet, if I remember right. I could be wrong, but it's in that range. The gun barrel in the Iowa class, on the North Carolina, they're 16-inch 45s. So they're shorter, so it has shorter range and less accuracy at a given range than the 16-inch 50. The Yamatos were 18.1 inches, 47s or something like that.
What is that?
Yes.
That big steel?
It's off of a Japanese battleship. I mean, it's really Japanese armor. Brought some pieces back to the Navy Yard. They took them to Dahlgren and they subjected them to fire to see if we were as good as we thought we were.
What ship was it from?
Because they were, I don't know, Japanese.
This was from a test fire then, not covered from a battle or.
That's correct.
Yeah.
I remember the plaque on it. I think they tested it at Dahlgren
Mhm.
using a 16-inch 50 shell. I don't know what the range was. I can't tell you all that. It's kind of hard to hit something this small at a very long range. So, but there's always been that debate if the Iowa class engaged a Yamato class, who would win? And the answer, at least from the sources I've read, is that probably the Iowa class, because of a higher rate of fire and a heavier shell. The Japanese shells are actually lighter weight than the 2,900-pound armor-piercing shells these barrel shot. I wasn't there. I don't know. That's what I've read. So that's all I've got. If there are any questions, hopefully that's kept us under.
Thank you.
Awesome.
Excellent.
And you're
Thank you.
Unfortunately, you'll hear more from me in another couple. Questions.
I have one comment, if I may, about the battleships and the destroyer escorts. In Lady Gulf, 1944, the
Yep.
Japanese were unable to actually depress their 18-inch guns low enough to be able to hit the destroyer escorts. They hit a couple of the DEs, and the 18-inch projectile was so powerful it actually went through the ship without detonating, and would detonate out on the water after it passed through. The other ones that really exploded on the ship was where they hit the main reduction gear. So the DEs, the small boys, gave a pretty good whipping to the Japanese themselves with much smaller weapons and being close inside. So the DEs really fought a very brave battle at that time.
Good point. Yeah, it's actually, good point. It does make the point that if you get in close enough, you're in an immune zone against a big gun battleship, if you can get there.
The last thing I wanted to offer was this. That was Chang on Cunningham, PG-17. We were on escort duty with the Iowa down off of South America doing a publicity type of a thing. And I have no words that can tell you just how powerful it felt when the Iowa did a broadside and we could actually see the projectiles flying through the air. To see it on a picture like this is impressive, but it's nothing compared to actually being there and seeing this beast flying through the air. Thank you.
Sure. I'll come up with a 3D presentation next time. With sound.
Okay.
Thanks for the comments.
Are people okay if we go straight into show and tell?
Yeah.
Can we have a couple minutes to try and get the 2 camera thing
Yep.
set up? I should
Okay,
have,
it's
I should have
50.
tried that before, like at home, but
You think you can do it in 5 minutes?
if I can't make it in 5 minutes, then we'll just do it the regular way.
Okay. So we're gonna do 5-minute break and then we're gonna go into show and tell. Show and tell, we'll do these 4 tables first and then we'll go online and then we'll.
Okay.
That's first. So wait a minute. I don't know if I have it.
If you're not on there, then I don't have it.
Yeah.
And I can always create that and you can just need this.
Well, I can't change it. I'll take care of it. Well, we did the first time. Not even know if I
Oh, this is our website.
Yeah, that's your, yeah, no, and I don't know my son.
Oh, no, no.
Well, you can't. That's right. You didn't, I'll step out where I get internet access to it. And that's the first copy. You have to access. Yeah. So,
Website username. He was.
That's the one. You pick whatever you want.
Yeah.
And you'll get an email today.
Okay.
That's what I'll do.
Keep this going.
Yeah.